Okay, so good evening, guys. We have already been on live. Okay, so let's start the class today. The first problem solving live class for all the statistics enthusiasts and data enthusiasts over there. And we have 5 exciting problems today. I hope our normals to like our intern students who are on Google Meet can see the screen properly. So we have 5 problems. We have one from real analysis, one from linear algebra, one from probability, one from statistics, and one from high school mathematics. And let's move ahead to the whole class forward. And let's do so. Any corresponding preference, guys? Tishika, Bhushan, Sneha, Vasudha, Sriteja, Nisha on the problem. Like which topic you want to solve first, guys? Any preference? Any preference? Yeah, 5. Okay, in any order. Okay, people are offering in. Okay, people are asking also real analysis. That's good. So let's do the real analysis first. So let's go to the first problem. We will try to do the 5 problems in 1 hour today, but we are not sure. We will give our best to solve the problems one by one. So the first problem for today. This problem is actually suggests like a doubt problem by Tishika. So we will not only solve the problem, we will do something more as always. So let's do it. The question asks that suppose for every function from like closed interval 0 comma 1 to r, which is twice differentiable, we have f dash x greater than equal to 1. Okay, we have f dash x greater than equal to 1 for all x between 0 and 1. The question asks that which of the options are true. So we have one option true. We can easily find out the solution, but we will not stop there. We'll find out counter examples to that so that we can totally understand the problem in its full entirety. Okay. So f dash x greater than equal to 1. So what does it mean? It means that this you can actually apply this result idea, guys, of always this idea. Let me write it down that if f dash x is greater than equal to 1, you can always integrate right on the right hand side. Let's say from 0 to 1, f dash x greater than equal to 0 to 1, or let's say x is less than equal to 1 dx over also dx over here. So we get that f of x, so let's call it u, okay, du, because of the same variable over here. So I'm also making you write how you should write in an examination hall for ISI like subjective portion. So if the fx minus f of 0 by like the fundamental theorem of calculus is greater than equal to x. So we get that fx is greater than equal to x plus f naught. So if you try to understand the picture in your mind, guys, about this, if you try to understand the picture in your mind, you will feel that maybe it's greater than equal to x, but it may be not, because it can start at a lower point than x, what it is 0. Okay, it's not told out like the what's the range is in, so it can start like this and it may never exceed x. So that's the idea, it may never exceed x, it can start like that. Depends upon where f0 is. If f0 is greater than equal to 0, then it implies that fx is greater than equal to x. So this is not always true. Okay, for example, fx is equal to x minus say 1, f dash x is equal to 1, is greater than, is actually equal to 1, but it's like less than x, so it's not true, right? So this option is not when we are given a counter example, okay, that fx is equal to x minus 1. Okay, let's also the first option. What does the first option say, guys? The first option says that f double dash x is greater than equal to 0. So what is the intuition behind this option that you must understand fully? What is the intuition behind this option? The intuition behind this option is the following, that okay, let me go to some other side. Oops, how to change? I guess, yeah. The intuition of this option is the following, that any questions, guys? Nisha?
Can you explain how like we cancelled the second option?
Sure. So if
Like
it,
your voice was cracking, if you could only repeat.
sure. So understand this, that did you understand that fx from integration we got that fx must be greater than or equal to x plus f naught, right, Nisha?
Yes.
So now what happened is that it depends upon where the f starts from the diagram. If you observe, it depends upon where x starts. So it can move in the same rate as x or more than the rate of x, but if it's lower than starts from lower than x, it will not be greater than fx, right? X, right? You understand? For example, if you take fx is equal to x minus 1, it starts, I mean, at f of 0 it's minus 1, which is less than 0, which is at x. Okay, x at 0 is 0, right? If you start at x is less than 0, I mean, sorry, x fx, which is x minus 1, it's actually less than 0, which is minus 1. So it's not greater than x, right? I hope you understood, Nisha. So if you take function fx equal to x minus 1, then f dash x equal to 1, but it's less than x, so it's not true, right? Always, Nisha. I hope you understood this. Did you? Hello.
Yes, I got it.
Yeah. Perfect. So now we have cancelled this option right here. Let's move on to the different. Let's select a different color if it's there. I don't know. No color, other color. So let's say. Let's take the first option. What is the intuition behind the first option? That f double dash x is greater than or equal to 0. The reason behind the first option is that suppose if you take one such option is what fx is equal to x is such a good function, right? So if you do if you double derivative fx equal to x, if you double derivative it turns out to be what? It turns out to be f double dash is 0, right? So it also tells that if f dash x greater than or equal to 1, it has the intuition that f double dash x may be greater than or equal to 0. But it may not be true. I mean, what implies that since f dash x is greater than or equal to 1, it's sort of f dash is always increasing, right? It makes an intuition. If f dash x is greater than or equal to 1, f double dash x must be increasing because f double dash x is the rate of change of f dash x. So it's a given intuition, maybe f double dash x is greater than or equal to 0. But it may be not. Why? It's because of the same idea. It's like asking the same question that let's say f dash x is equal to gx. Then what is happening? Then what is asking that f g double dash x, g dash x is actually greater than or equal to 0 or not, if this is greater than or equal to 1. It's asking that if a function is greater than or equal to 1, is its derivative always greater than or equal to 0? No. I mean, you understand it's no, because it can be decreasing like this. Let's say if a function is greater than or equal to 1 between 0 and 1, let's say I'm drawing gx over here, and let's say this. Let's say gx is equal to 1 minus x. This function is greater than or equal to 0, but it's decreasing. G dash x is less than is equal to minus 1. So it's a counter example this. So we have got that f dash x is equal to 1 minus x is such a function. And let's find fx. So fx, if you just integrate it, we get that it's x minus x square by 2 is such a function. Okay, if you do f dash x, is you get the what? You get 1 minus x by 2. Okay, and if it's greater than or equal to 0, I guess 1 minus x, which is greater than or equal to 0, greater than or equal to 0. Sorry, greater than or equal to, am I doing some mistake over here? Am I doing some mistake over here? Yes, gx is told to be greater than or equal to 1. I'm so sorry, I have taken greater than or equal to 0. I'm so sorry, I have to erase it. Just give me a moment. So what we are looking for is the following function, guys. That we are looking for a function if we are looking for this f dash x is greater than or equal to 1 and f double dash is greater than or equal to 0. So if we replace f dash x by gx, it's equivalent to gx is greater than or equal to 1 and g dash x is greater than or equal to 0. Oh, it's telling that if the function is greater than or equal to 1, let's say this is 1, 0, 1, 1, but g dash, so it's like take this function. Okay, that is 2 minus gx. So gx is equal to 2 minus x, which is always greater than or equal to 1. You can understand it. And g dash x is actually minus 1. So it's not true. So let's find out f dash x is equal to 2 minus x. So we get fx is equal to 2x minus x square by 2 is such a function. Okay. And this function is such a function which is actually follows the given condition, but f double dash x is greater than or equal to, is not greater than or equal to 0. Okay. Did I understand all of you guys? Any questions over there? All of you understood this idea? No, Sriteja, what didn't you understand? Tell me. Which part didn't you understand? Can you unmute yourself, Sriteja? Oh, no questions, you mean? Okay, fine, good. Tishika, did you understand? Nisha?
If we take gx equals to 2 minus x,
So the replacement part I
if
didn't
we
get it.
One by one. Nisha, yeah, go ahead.
if we take gx, that is f dash of x, as 2 minus x,
Mm-hmm.
and then we try to calculate f double dash of x, so that comes out to be 2, right?
No, g dash x is -1, right? It's 2 is a
Okay, sorry.
Yeah.
Sorry.
Yeah, and Tishika?
The replacement part I didn't get. That you substituted g of x.
Oh, I told that what we are required to find out. The given condition is f dash x is greater than equal to 1, and it asks about f double dash x is greater than equal to 0. So I'm just asking that instead of f dash x, just write f dash x is equal to zx. Okay, and f double dash x is therefore g dash x. So we are required to find a function which is f gx is greater than equal to 1, but g dash x is less than 0. That's what we are required to find, right? To find a counter example, and that's what we found over here. You understood? Now gx is equal to f dash x. So we have found out that f dash x is equal to 2 minus x. So let's take fx is equal to 2x minus x squared by 2, which follows the given condition. Tishika, did you understand?
Yes.
Are you sure?
Yes, got it.
Okay, fine. Good. Yeah, tell me.
G dash x, you wrote G dash x is greater than 0, and then we have got G dash x is equal to -1. I've not understood this
No,
question.
okay, no. See, this condition is same as this. So we are trying to find a counter example for each of the options out there. So this option is such that this is less than 0. It's a counter example to this, right? Gx is greater than equal to 1, but g dash x is less than 0. Right, Sneha? Did you understand?
Yes.
Did you understand now?
Yes.
Sure.
Yes.
So we are finding a counter example. So this is not condition is not true. Okay, so we have found a counter example to this first two like options. Let's go on to the other options. The other options are really easy. And Tishika, these options are really applications of mean value theorem. Okay, so let's see what it's looking for. If you just understand what it's written over here, it's telling you that f of x2 minus f of x1 by x2 minus x1. Can you tell me, Tishika, what is this? Because since it was your doubt.
F dash x.
F dub what?
F dash x.
F dash of
X.
what is x? What was mean value theorem? It tells you that if two points are there, there exists a point in between. So x is such a point. We often write it xi. Okay, so xi is such a point between x1 and x2. Okay.
Yes.
It's like not any f dash x. It's like a certain f which is dependent on x1 and x2. So now we know this is greater than equal to 1 from the given condition, right? So what we know is that since x2 greater than x1, let's take this one. We have got that f of x2 minus f of x1 is greater than equal to x2 minus x1. And I think you will get the third option correct over here. Okay, just check it out. So this is what we have got over here. Okay, so we have got all the counter examples over here and everything out here which resonates with the whole idea of the question. Good. Any other questions from the audience from the YouTube stream live? Any questions from about this question? Any doubts regarding this question? Okay, lovely. So let's move to the next idea. Next idea is that I will go into the probability aspect. The probability question is really interesting this time. It's not probability, it's a yep. So let's do this probability question, guys. Okay, the probability question asks the following. So if you just search, this is actually called just give me a moment. This is actually called, thanks Spondan for this prompt answer, how to change the color. Law of succession. It's by Laplace, okay? Laplace law of succession. So actually Laplace used this problem, to guess that the odds of the sun rising in the east tomorrow is actually something, some 18 lakh or something, what is the age of the, what I don't know, is to 1. Okay, that's like a whatever his idea of probability and sun was. The next one is that, okay, let's do this problem. So it's an investment, you can take it as a finance problem. Okay, the so let's say there are S1, S2, .sn commodities. Okay, so those people who are preparing for 2022, make sure that you are quite comfortable with the conditional probability. Okay, otherwise you may have a little difficulty in understanding. Let's focus on this problem really very like on a focused manner. Okay, so S1, S2, .sn are a large number of commodities, n commodities, capital N commodities, in which you are going to invest. And Si commodity has a probability of going up is I by n. Okay, that is Sn has a probability of 1 of going up. So different years behave independently. So you can understand by by multiplicative rule of probability that the probability of Sk going up is, it's a hint, probability of Sk going up is in the next small n years, let's say Pn, is k by capital N whole to the power n. Okay, that's the probability of it going up, right? So now try to understand this. What as an investor, what you're really trying to find out? As an investor, you're trying to find out that first of all, you don't know which commodity to invest, which commodity is SI. Okay, which you don't know that. And actually, it's a very practical idea. You don't know which commodity is SI. So we invest in one of the commodities C at random. So what we do, we invest in one of the commodities C at random. Let's say we are investing in C at random. Okay, and then it goes up n year in a row. What is the okay, it goes up n years in a row. It goes up n years in a row. The question asks that what is the probability that it will go up next year? So try to understand the question. See, as I will tell you again and again every single time, that the probability questions are more, you first try to formulate the probability question, okay, in mathematical terms, then only everything will become easier. Okay, otherwise you cannot really find out what we really need. That's why the probability is really challenging and really exciting at the same time. So let's try to understand what we're really looking for. We're really looking for what? Let's try to define the random variables over here. That's always the step number 1. Okay, remember that. Define random variables. That's step number 1. Never forget that in your life. Define random variables. So what are the random variables over here? C is one random variable. What is the C? C denotes commodity picked at random. Commodity picked. And its sample space is C1, C2, Cn. Okay. The next one is what? The next one is Un. Is that the random variable, like the selected commodity, okay, grows or goes up. Understand Un is actually dependent upon C. You have to understand it intuitively. Un is dependent upon C. And this is the first step which makes you understand, okay, guy, okay, this makes me clear. Okay, this is the time I have to apply conditional probability. Why? Because one random variable is dependent upon another random variable. So to find out the probability, we need to condition of the given random variable C, and then I have to find the quantity, the probability, right, guys? That's what we need to find. So we have Un, which is the selected commodity, will go up, and we have the C, the commodity that you are selecting, which you don't know, it's a random quantity. So the probability, because it's C, it depends upon C1, C2, C2 dot Cn commodities are there, right? So the probability of going up depends upon the Ci, the commodity. That is, it probably depends upon the commodity C, the random variable C. So this is the point of time you must understand. You have to condition on C, otherwise you cannot really do it. Okay, that's the first step to understand problems related to conditional probability. You have to first write down the problem mathematically. So what you're doing over here, you're doing, so UN is the selected commodity, the price will go up. That's the like commodity, like that is the random variable. Okay, we'll find out probability of UN. So what is required to find out over here? The required to find out over here is the following. Required to find out RTF is probability. It will go up in the nth till n years. This is what we are required to find out, right? The probability it will go up in the n plus 1th year, given that if we have gone till n years. Right, guys? Did you understand this part, guys? Tishika, Bhushan, Sneha, Vasuda, Sriteja, Nisha, Shoikot. Did you understand? Any doubts from the YouTube viewers also? Any doubts? Did you understand the whole framework, guys, till this point of time? No doubts? Okay, so let's move ahead to the, okay, good. So let's move ahead to what we are required to find out. We are required to find out probability of U of n plus 1 given UN. So understand this is same as actually probability of UN, comma UN plus 1 comma UN by probability of UN. Now UN is a UN plus 1 implies UN, right? So it's same as probability of UN plus 1 by probability of UN. So it will go up to in the n plus 1th till the n plus 1th years, given that it has grown till the nth year. That's the probability. This is the probability. So what we are required to find, therefore, it demands you therefore to find out. It demands you therefore to find out what probability of UN. Now probability of UN is connected via C random variable. So this demands also to condition on C, right? It demands on, sure, Satej, we will, I will tell you. So what is the conditional part? Conditional probability part is the following, Satej, is that, see, first close your eyes and understand this, that we are selecting the commodity. So UN is the selected commodity, UN is the probability that the UN is the random variable, so the selected commodity will go up, the price of the selected commodity will go up. So now understand that the price of the selected commodity will go up. Its probability is dependent through the value of C, that is C1, C2, C3, Cn. If you go through the problem, it depends, like C I ka different probability of going up is there. C I ka I by n probability is there, okay? S I ka, it should be SI, okay, not CI. So therefore, UN is dependent via on C, okay? That's why you need to condition on C to find out the probability of UN. So probability of UN is now we have to find out and condition on C. And how do you find out? Can you guys tell me what it is called? How, when you condition on certain stuff and find out the probability? It's one word. So when you have a lot of, when you condition on a probability and the probability depends upon conditional, like conditional paths, what do you find? What do you do? It should depend on C. That's why we should taking condition. So that's why taking on conditions over here. So what it's told, it's simple. Law of total probability. Lovely. It's called law of total probability. It's dependent upon law of total probability. So we are conditioning. So it's like, so UN comma C1, right, plus UN, comma C2, right? All the commodities. That's how you do it. It's intersection, partitioning the whole set, UN, comma CN, right? And what do you do? And therefore now you need to find out this intersection by conditional probability. It's like UN given C1 into probability of C1 plus dot dot dot. So you get its summation of I from 1 to n, okay, probability of UN given Ci into probability of Ci. Now let's see what you know. You know that probability of Ci is what? It's 1 by n. You're randomly selecting the commodity, right? And you know probability of UN given Ci. You know that what is the probability of UN given Ci? That the given the commodity Ci, what it will go? You know that. That is this. I k by n whole to the power capital N. So what do you know? It's same as summation of 1 by n. This is 1 by n whole to the power small n into 1 by n. Am I doing it right? I hope so. Yes. So we have this condition over here. So this is what the probability of U is. Do you understand, guys? Any doubts? Any doubts? Yeah, for large values of n, this can be approximate integrals. Exactly. So that's what we are going to do over here for large values of n. So now try to understand this. So mainly to the 2020 people in our batch and also other people in the YouTube streaming, understand that this. Can you just understand that which is this related to? This is something related to if n tends to infinity, what will happen? On this probability, what will happen? Try to understand. Actually, if you can find out an integration of a to b or 0 to 1, say fx dx can be approximated as Riemann sum limit capital N tends to infinity 1 by n, n from 1 to k from 1 to n, f of k by n, right? If you remember this result, guys, this was the idea, right? This was the limit. So this limit goes to integration 0 to 1. It's x to the power n, right? K by n whole to the power n. So that is fx is x to the power n, x to the power n dx. And this is actually what? This is actually 1 by n plus 1. 1 by k small n plus 1. Right? So probability of un is actually 1 by small n plus 1. And therefore you have found out the probability of this is equal to n plus 1 by n plus 2. Okay? This is the beautiful idea about this problem. Yeah, actually it asks you about this, like what will happen. I mean, it's like a general aspect. What is the probability will go up next year? So it like sort of invites you to ask that when n tends to infinity, what will happen? Okay. So that's the beauty of this question. But yeah, you're right. It's not given sum. You're right. Okay. So Dibbangana, I didn't get you. Which part you didn't understand, Dibbangana? Can you just explain? Which part you're telling? By the way, all these people over here, Tishika, Bhushan, Sneha, Vasudha, Sweetaja, Nisha, Shoikot, everyone, you understood? Any doubts in this? Okay. Dibbangana, can you explain it to me? What is your doubt over here? Sure, we'll explain the integral again. If you remember, this guy is Riemann integration, the RTF part. Okay, sure. So there are two doubts over the RTF part. So RTF part, understand this. Did you understand? I hope you know and understand till this point. Now understand, UN means that the selected commodity goes up till the n years. So UN plus 1 means what? The selected commodity will go up till n plus 1 years, and UN means, so it's like probability the selected commodity will go up till n plus 1 years, and the selected commodity will go up till n years. So selected commodity will go up for n plus 1 years implies that like UN plus 1, this event implies UN, and it's and. So UN plus 1 intersection UN is actually equal to en, like UN plus 1. Like, so that's why it's this Dibbangona. I hope it's clear now. Yes, that was actually a hint, Pratik. You're right. Okay, coming back. Yes, that's right. So coming back, coming back to the conditional part, the Riemann integration part. So the Riemann integration, let me explain it once again. Summation of 1 by n, f of k by n, k from 1 to n, limit n tends to infinity is actually equal to integration 0 to 1 fx dx. Why this is true? This is very simple. Let's take this 0 and 1. Let's divide it at 1 by n intervals. Dot dot n minus 1 by n. This is n by n. This is 0 by n. So if you see the integration over here, so this is the height. If you see, this is the height. The integration explains this. So this is the sum over here, and the integration is this, the normal area. So as n tends to infinity, it becomes smaller and smaller, and therefore the area under the curve reduces to this sum. I hope you understood it now. Okay, and Bhushan, did you understand this now? Good, very good. So this is a beautiful problem, and this was done by Laplace in his years of probability when he was there. So I really love this problem. So it's a connection to the investment and finance stream also. So I really love this problem. I hope you enjoy this problem too. Let's move ahead to the next problem. The next problem, let's say it's on. Let's say, okay. This is a statistics problem. This is problem that will be involved. It's a bit longer problem. Let's see. So any suggestions, guys? Which question, which subject you want to try now? Statistics, high school mathematics, linear algebra. Which one? Okay, let's do linear algebra. I really love this problem of linear algebra. Let's do the linear algebra. Yes. Okay, this is a really interesting problem. This doesn't require at least anything of linear algebra. Okay, I love this problem absolutely. So this type of questions, actually remember, this type of questions came in my ISI, okay, when I was in second sem. So it was an open notes examination, and there you need not any mark up any formula, okay, just enjoy the problems. And I love one of them problems was this. Let's do this problem, okay. So the determinant of a square matrix with integer entries, okay guys, this determinant with square, it's a square matrix and it's integer entries, and that is, let's say an example, a b c d, all integer entries. It's the determinant is plus minus 1. So it's asking that a x is equal to 0 has any has a integer solution or not. These two are integer coordinates. X belongs to z to the power n or not, let's say, like integer coordinates or not. That's the question. That's the question, guys. Okay, now we cover the probability problem, right, Pratik? We finished the probability problem, right? It's now the linear algebra problem. Okay, so okay, let's coming back to this linear algebra problem now. So let's when you're trying to do this problem, guys, let's say what would have happened if x and y are not. See, if x was not required to be an integer, does it have an integer solution? Does it have a unique solution, guys? Okay, sure, Pratik. So what do you think? Yeah, so Tishika, Bhushan, Sneha, Vasuda, Sriteja, Nisha, Shoikot. What do you think that suppose x was not required to be an integer solution, then does there exist a solution, unique solution? What do you think? And all the YouTube people over here. Suppose x, like x was not required to be the integer coordinates, okay? The question is now mine that will it be an unique solution? Does there exist a solution? What do you think? Sneha, Vasuda, what do you think? Nisha? You think yes. Why do you think? Like, what is the reason? All the YouTubers, YouTube people over here. Exactly. A is full clear lang. Lovely. A is invertible, right? A ka determinant is non-zero. A ka determinant is non-zero. Therefore, inverse exists, right? You can clearly understand that A ka determinant is non-zero and inverse exists. So, if x was not a given condition that x has to be an integer, what you take? You take x to be A inverse of z, A inverse of y, right? And if there exists a solution, so to understand this, if there exists a solution, it has to be only A inverse of y. Try to understand this, that if there exists a solution, since it's invertible, A inverse exists, the only solution is A inverse of y, right? So what does the question reduce down to? The question reduces down to the fact that whether A inverse y is an integer, the coordinates is are integer or not, right? That's the question reduced down to. Did you understand this, all of you, this point, guys? Sneha, Vasuda, Nisha, Sriteja, Tishika, Bhushan. Did you understand this point? All of you over in the YouTube. So the only solution that can exist is A inverse of y. So the question therefore boils down to ask that whether A inverse or y has an integer coordinates, if A and y has integer coordinates or not. That's the only question it reduces down to, right? That's the only question that we are going to focus on now. So therefore, let's focus on this problem now, a subpart that is A inverse y integer? Is A inverse y, does A inverse y contain integer coordinates, integer entries or not? We know that A contains integer entries. We know that. Now we want to know that whether A inverse contains integer entries or not. I'm really sorry for my bad handwriting, okay? Please forgive me, but I will try my best. Okay, Dibbangana, no is for which answer? Didn't you understand, or it's like some other question? Okay, so the question therefore boils down that if given A has integer entries, whether A inverse have integer entries or not. Now, a small hint for you for next 1-2 minutes is that can you use the condition now that the determinant is plus minus 1? Can you now infer about the entries of A inverse? Do you remember how the A inverse is created? Do you remember the algorithm of how A inverse is created? Can someone tell me how A inverse is created? What is the algorithm of A inverse? How is the A inverse matrix is found out? Can someone tell me? Dibbangan, I didn't understand what you tell no to. Is like regarding the doubts, or didn't you understand something? Yeah, perfect. No, Pratik, one thing is sorry, Satej, one thing is that yeah, the inverse is unique. Okay, and since it's invertible, it has only left inverse is equal to right inverse. You can prove that. Okay, that's not a that's not a problem, Satej. The problem is that uh, whether A inverse Y is integer or not, because now we can. There's only one possible. Okay, yes, exactly, perfect. Spandana and Pratik, that A like the in A inverse the entries are what? Adjoint of A at that point, adjoint of A by determinant of A. And determinant of A is plus minus of 1. So what we get now? Determinant of A is plus minus 1. So therefore it boils down whether adjoint of A is does contain integer coordinates or not. So we know that A inverse is equal to adjoint of A by determinant of A. That's how we form. Now therefore it's equal, therefore it's plus minus adjoint of A. So therefore it boils down that to ask the therefore I ask the question that whether adjoint of A contain integer entries or not. That's the first question now. So can you guys tell me what is the definition of adjoint of A? Tishika, Sriteja, Vasudha, Bhushan, Sneha, Nisha. What is the adjoint of A?
Transpose of cofactors.
Exactly, cofactors. How do you find out adjoint of A? Suppose A is here. So how do you find out the adjoint of A? This is the algorithm. You for the ijth entry, what you do, you delete this two columns and rows, and whatever matrix is left, you take the determinant of it, depending upon the like minus 1 whole to the power position I plus j, I guess. The ijth entry of this is actually like deleting these two this rows and column, whatever the matrix is left, which is the determinant, and A contain all the integer metrics. Therefore, each of adjoint of A ka ijth entry is integer. Why? Because A ka like determinant of a matrix with integer entries are integer, is an integer. Right, guys? All of you understood this? Any doubts? Determinant of an integer matrix with an integer entries is an integer, right? Clear? Bhushan, Sriteja, Nisha, Vasudha, Sneha, Tishika, are you understanding? Good. So therefore, what we have got over here, we have got therefore the adjoint is an integer, and therefore the A inverse must be an integer. It's a beautiful problem. A inverse must have integer coordinates. Must have integer entries. And therefore, A inverse of y is also integer entries, must be all integer entries. Integer entry. And therefore, it's true actually. Next day, what we will do is we will yes, exactly. We will expand this problem to other possibilities, okay? Yeah, so okay, so that's a very good question about asking that how that person should write that adjoint of integer is adjoint is an integer. That's why exactly. So you write this that adjoint of A ka ijth entry is what? Is actually determinant of a matrix with integer entries. Since A has integer entries. Maybe you can draw a picture like this. they will understand. I mean, surely if you draw this picture, they will understand. This is a way to write. Okay, thanks for asking this question. Yeah, sure. At least they expect this kind of mathematical maturity from you, Pratik. Okay, that they expect it from you. Okay, all of you understood this question. Next day, in the next live session, I will do, I will take other examples. Okay, plus minus 2, plus minus prime number, whether it will have prime number solutions or not, like something like that. Okay, but okay, we will use that. Okay, I hope you understood that. Okay, I will end this session today by the statistics problem. It's a long problem, so I will end this today. And it's a beautiful problem. It came in the second year, first year, second semester question of ISI, like of the MStat, of the BStat people. Okay, so this is the question. I love this question absolutely. Like two random variables x and y. Okay, two random variables x and y have two distinct values. Okay, try to understand the problem very carefully. Two random variables x and y has two distinct values. They're independently distributed if and only if their correlation coefficient is 0. Okay, so two random variables x and y takes only these two distinct values, prove that they're independently distributed if and only if their correlation coefficient is 0. Okay, another thing, coming to this question, can you tell a continuous random variable, two continuous random variables coming from a certain distribution, if they are independently distributed if and only if their correlation coefficient is 0, can you tell me such continuous random variable? It's a really important result and a really unique characterization of such continuous random variable. Can you give an example? So
Bivariate normal.
perfect, lovely. So normal distribution is such an example of a continuous distribution where if you take 2x and y coming from normal, they're independent if and only if the correlation coefficient is 0. You can prove it. Okay, it's because of when you multiply it, the correlation coefficient coming up to be in the top, it will come out. Yeah, you're right, Pratik. Coming to top to be, it's like you can easily find it out. It's fine, like x square plus y square minus rho xy. So rho is 0. Then it will, the whole thing will distribute. Okay, that's the idea. The whole thing will distribute. Yeah, you're right. So let's focus on this problem. So focusing on this problem, we get the following. Try to understand. Focusing on this problem, we get the following, that so how we can geometrically visualize this problem. There are certain important steps you must focus on this. How we can geometrically visualize this problem? First, number one, by a contingency table. So it's A. Let's say x takes values A and B, and y takes values C and D. Okay, try to understand this. This is very, very careful. Try to understand this. X takes values A and B, and y takes values C and D. So now, understand this very carefully. That, okay, what we require to find? Correlation 0 if and only if independent. So we'll make some assumptions. Understand that, suppose, so understand that independence doesn't depend. First, some of the observations, okay, you should write like this. Observation 1, that independence, x is independent of y, does not depend upon the values of x and y. That is, it doesn't depend, it's take A and B or A dash or B dash. Okay, it just depends upon the probabilities. On the probabilities, okay. This is the first observation. Why we are doing this? Because we are trying to reduce the algebraic jargon over here, okay. That's the first step. Next step, So why are we doing this? You will really understand it now. Because correlation coefficient needs these values, okay? So that's why we try to reduce the number of variables over here, A, B, C, D. We're trying to reduce the number of variables. Now also observe that expectation correlation is actually correlation of x comma y is actually same as correlation of x minus mu x comma y minus mu y, right? Can you tell about this? If we shift the origin, it will remain the same, right? Correlation of x comma y is same as correlation of x minus mu x comma y minus mu y. Can you agree with this? All of you? It's very simple to understand why. Let's prove this up. Because expectation of xy minus expectation of x minus into expectation of y is same as expectation of x minus expectation of x, which is mu x, times expectation y minus mu y. Okay, and it's 0, right? So therefore these two are equal actually mathematically. So what we will do is that we will change a comma b. So we'll define like we do a, we change a comma b. Sorry, what we are doing? I'm so sorry. A to a minus a plus b by 2, and b not b by 2. If you just change it, observe that one thing you must observe, that if you take it to be okay, one thing you can just give me a moment, let me think. Can you take it to be a and minus a? No, I guess. Okay, I was thinking of converting a to be a and b to be minus a, but will that help? No, because the expectation cannot be. Yeah, it can. Oh no, it cannot help actually, because it's not equal. Okay, I understand. So what we can do is that, okay, let's do it with a b c d. Okay, only. Okay, let's do it with a b c d. I think this will not help. Okay, let's understand now the idea about the independence. How to understand from this contingency table about the independence. Okay, x takes a and b, and this takes c and d. Yeah, you're right. Now let's take, this is p. This will also help you understand joint random variables. Okay, let's say this is p. This must be 1. And what this will be? No, let's not take this to be p. Let's take this to be p. This will be 1 minus p, the marginals. This to be q, and this to be 1 minus q. Let's take this to be alpha. You will see this is the deciding factor, and this will turn out to be q minus alpha. This will turn out to be p minus alpha. This will turn out to be 1 minus p minus q plus alpha. Okay, let's try to understand this. That what is meant by algebraically by independence over here. Observe that alpha, it's independent, x is independent of y. If and only if, can you tell me why alpha is equal to? Can you tell me what is alpha? Tishika, Bhushan, Sneha. What is independence? It's very simple. X and y is independent if and only if alpha is equal to
PQ.
Lovely. PQ. Who was this, Sneha? Lovely. It's equal to PQ. P into Q, right? It's a marginal. It's a marginal of x. This is a marginal of y. It's equal to PQ. So therefore, what we have to show algebraically is that it's the following, that x correlation of xy is equal to 0 if and only if alpha is equal to PQ. Okay, guys? So that's what we have to show now. Let's try to find correlation. Let's try to find correlation. We will just find out the value of correlation. So let's try to find out the correlation from here. So correlation is what? Let's try to find out x and y. So why did I do x and y? This is okay. Let's try to understand this. It's AC with probability alpha, AD with probability Q minus alpha, BC with probability P minus alpha, and BD with probability 1 minus P minus Q plus alpha. A lot of variables over here. You have to must be careful with this. That's why it was a 15 marks problem in our semester examination. Okay, let's find the expectation of X. It's really clears your basic, you know. I love this problem. So X ka expectation of xy, let's write it down. It's equal to sum of this. Okay, it's weird. And X ka expectation is what? It's A times, let's see, A times Q plus B times 1 minus Q. You have to be prepared for do this type of calculation, okay? A times Q plus B times 1 minus Q. An expectation of Y is C times P plus D times 1 minus P. An expectation of XY is AC times alpha plus AD times Q minus alpha plus BC times P minus alpha plus BD times 1 minus P minus Q plus alpha. Okay, let's try to find out expectation of X, Y minus expectation of X times expectation of Y. Now this is a very challenging task. The challenging task comes up because there are a lot of variables. What do you have to understand? We need to prove what? We need to prove that it's equal to, if and only if it's equal to 0, if and only if alpha is equal to PQ, right? That we need to prove. So we need to do something such that we get alpha minus something over here, right? So that's the thing we need to do. So remember, we need to get this term alpha minus PQ common from all of this. So remember, we need to arrange that in that manner. So like we need to get this as alpha minus PQ times something. This is equal to 0. So we will get this term out. So this is the sense of algebra you must have, okay, as a high school mathematics person. Like knowing the high school mathematics well, that's why it's like written over. Okay, so let's try to find out like how do you find out this in that. So AC, I will write it down short. AC alpha plus ADQ minus AD alpha. I'll just do it in front of you, okay, so that you understand that we have to work a bit hard to do this. BD minus BDP minus BDQ plus BD alpha minus AQ plus B minus BQ times CP plus D minus PD. So let's clear it over here. Minus we get ACPQ plus AQD minus APDQ plus BCP plus BD minus BBT minus BCPQ minus BDQD plus BDPQ. Okay, we can erase this now. So we have this now. So let's try to see whether there's some cancellations or not. There must be some cancellations, okay? It's a natural way. Let's try to write it down. Minus ACPQ minus AQD plus APDQ plus BCP plus BD minus BPD. Sorry, I'm doing something wrong again. Minus BCP minus BD plus PDB plus BCPQ plus PQD minus BDPQ. Let's erase this up. If you have already found out certain cancellations, do let me know. Make my life easier and yours too.
BCP.
BCP, okay, lovely. Thank you so much. BCP is getting cancelled. BCP, 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 BCP kahan gaya? BCP over here. Yeah,
BD.
lovely. BD, 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 lovely. Okay, nice. Other BP.
AC alpha.
This is
and
also
ACPQ.
cancelling. AC alpha,
Q.
AC alpha, AC alpha, AC alpha,
ACPQ.
ACPQ. Where is ACPQ? Other ACPQ.
ACPQ will not be cancelled. AC will be
Alpha,
alpha
alpha.
minus PQ.
Alpha minus
Coming
PQ.
common.
What else? What else? Any other cancellations? I think BDQ. AQD, AQD, AQD. All these three terms are cancelling, okay? BD alpha. All these four terms are here. All these three terms are here. Oh, no other cancellations. Okay, let's rub this off. So rub this off. Okay, so we have got. So what we need to find? Remember, alpha minus PQ is the term we want. So let's combine that together. AC minus. So you got this. These two terms must be coming together. Okay. AD and ADPQ, 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 ADPQ. These two terms must be coming together to get alpha minus PQ. BC alpha, BCPQ, BCPQ. Yeah. So this term must be coming together. And BDQ alpha, yeah, this term must be coming together. Right. Must understand how we logically progress towards this problem. You must understand that. We have to sometimes think backward. So AC is there from common. It's like alpha minus PQ. For this, you have got AC. Let's cut this out. Here, minus AD.
Minus BC plus BD.
Good. Thank you so much. Minus BC plus BD is equal to 0. Good. Lovely. Okay. So we have got that it's equal to. Now we have to check it why this is not the thing. So I think there is another factorization over here. It's AC. Yeah, it's C minus D. So C minus D times A minus B is equal to 0. So it tells you that either A is equal to B and C is equal to D. Where did it go? A is equal to B or C is equal to D, or so we know that we have given the condition that all of them are taking two distinct values. So therefore it cannot be independent. Can you tell me why if A and B are A and A, if one of them are equal, then why it is independent? Because it's coming out that it can only take that only possible value, okay? So that's why it's becoming independent, and that's the idea. So therefore it's if and only if this cannot happen. So therefore A alpha must be equal to P. It's if and only if. All of you got this, man? Guys, all of you got this? It's beautiful, yep. All of you got this idea? Any doubts? Sneha, Tishika, Sriteja, Nisha? Any doubts? Clear? Did you understand this, Tishika, and all the people who are giving 2020 exam? 2022, sorry. Thank you. My pleasure. Yep. Okay, lovely. Thank you so much, guys, for your time and for enjoying the class. I hope you enjoyed. And if you like the session, don't forget to like and subscribe to our channel. And yep, so please be there for the next session. And please share it to your friends in your college and your juniors since it's free. If you share it, it will be really good for our efforts to spread the love of statistics and like data, what we are having inside of us, the passion to share the knowledge. Okay, thank you so much, guys, for your time. And good night. Stay tuned and stay blessed. And don't forget to like and subscribe and share. Okay, bye bye. Thank you so much. Satej, I'm not planning to cover usual exam problems in this okay, because it will not become such interesting. So we can surely do that, include one or two, but we will be doing interesting problems that can enjoy that can enlarge the like beauty of the statistics and data. Okay, thank you so much, all of you guys. Bye bye. Thank you, thank you. I hope. Do you have any questions, guys, regarding the session? Otherwise, I will end the session. Sneha, Tishika, Sritaja, Nisha, did you understand? Okay, lovely. Okay, bye-bye, good night, guys, and yep, do share to your friends. Request from my side and Cheenta Statistics Department. Thank you so much. Bye. Thank you, guys. Bye-bye. See you in the next video. The next session is on Thursday, and I will see you in the next video. We will be doing the rest of the problems in the next session, and similarly other problems like more like we are trying to cover 5 problems, one problem from each topic, but these questions are really beautiful, so we cannot really go ahead. So yep, that's it. Thank you, guys. Next Thursday, every Thursday, we will send you the mail, and there's some WhatsApp group of ours. If you want to join, do check out the links in our the YouTube links in our like channel. You can get the WhatsApp link. You can go to our website. You can also get the WhatsApp link over here. There's also now a number given in the website. You can like talk to me using the number. Okay. Bye bye. Thank you, guys. Bye bye. Good night.